Hey physics peeps, we're going to look at determining speed from a position versus time graph. When you are given a position versus time graph, the speed is the same as the slope. And you already know how to find slope as y2 minus y1 over x2 minus x1. So you could do that in this case by using this line, and you're looking for the slope of the section. So from where it starts to where it finishes. So we would say y2 is we go to the second point and we follow it to the y-axis, and it's 10 minus y1, go to the first point in the y-axis, 0, over x2 would be from the second point down to the x-axis is 5 minus the first point on the x-axis is 0. We get 10 over 5, which equals 2. The units for slope, or for our slope, is going to be the units for our y divided by our units for our x. So we are y units, or meters, divided by our x units, which is seconds. We get meters per second. And that's how we can find our speed. The greater the slope means the greater the speed. The less slope there is, that means the smaller the speed or the slower it's going. There is another way of doing this though, and it's by using something that we've used before, where if you're looking for speed or velocity, and remember that those two are the same thing, they're kind of synonymous, speed and velocity. But if we use the equation that we had used before, speed is the distance divided by time. We could do that for this section as well. We just say the distance, it traveled 10 meters, divided by the time, it went for 5 seconds. And we end up with the same answer as we did before. Either way works. I'm going to probably show using this, but you can feel free to use the slope any other time that you'd like. So when we look at a graph, like the next one here, there are 4 runners. There's Abby, Betty, Cindy, and Dana. And you could tell who's actually fastest and who's the slowest on this, or in this race. We would say that Abby is probably the slowest because the slope of her line is more shallow. It doesn't have as great of a slope as the other people did. And it goes like up to and over 4, all that stuff. But if you look at Cindy's is a little bit more steeper than Abby's, so she would be next. And Betty and Dana actually have the same speed because the slope of their lines are the same. So they would have the same speed. We can also figure out exactly how fast these people are going by figuring out either the slope or just using that equation v equals d over t to solve for the velocity for each person. If we wanted to do that for Abby, we would take velocity, or speed, is distance over time, and we would take the distance she ran. We look along the position side. She went from the beginning to the end, 200 meters in from 0 to 80 seconds. It's 80 seconds. And if we divide those, we get 2.5 meters per second for Abby. For someone like Cindy, if we wanted to figure out the velocity for Cindy, again, it's the same thing. Velocity is distance divided by time. But this time when we do the distance, you need to make sure that it's only for that section. So from where she started at 400 meters to where she ended, She ended at 600 meters. She only goes 200 meters for her distance, divided by the time that Cindy ran. And Cindy, from where she started, if I follow it down, she started at 100 seconds and she ended at 140 seconds. So be careful of that. The time's not 140, it's just 40 seconds in between. And I divide those. If I divide those, I get 5 meters per second. So that's how I can find different speeds on here. I could do that for Dana and Betty, but I think you guys will be good. All right. Have a good day.